Hello and welcome to the second video of the Cinema tutorial series. This time I want to explain in detail on how the Cinema Reader, Cinema Query, Cinema Layout and Cinema Writer work. But let me start with a quick recap of what a Cinema database is. So a Cinema database is basically just a folder with the extension .cdb and can contain any files. So here we see the TTK data repository, and here we have two Cinema databases now inside. And let's, for example, just look here at this viscousfinger.cdb folder. And like I said, this folder can contain any files, in this case VTI images. And the only required file that the database always looks for is this data.csv file, which is basically a ledger. So let me open this file with a text editor, for example, gedit. And as you can see, this is a standard comma-separated value file where the first row specifies the column names and the remaining rows specify the database content. Column names can be anything with the exception of the file keyword, which indicates a file path. As you can see, the data.csv file provides context for these files. So for instance, we can see that the file with this path here corresponds to simulation run 01 and has timestamp 4. Okay, but before we jump to ParaView and TTK, which uses these databases, let me show you an easy way of turning your data repository into a Cinema database. So very often I'm in a situation where I have a bunch of files where each file corresponds to a timestamp of a simulation, and I have additional parameters or something. So now I want to convert this data into a Cinema database so that I can work with it in TTK. So I already prepared an example here. I have a temporary folder here, and this just contains two subfolders where each folder corresponds to a simulation, and in each of these I have a time series. So each file is a timestamp. In this case, the files are already in a VTK file format, so I don't even have to do some conversion. But if that would be necessary, I could, for example, use ParaView to convert the data. Okay, but right now it is already VTK, so I just need to create the ledger, the data.csv file. For this, I just navigate to the root of my database, in this case, this folder that contains the two subfolders. And now I automatically generate a ledger by running find.-name star.vti, which will just look for every file that ends with this extension in my current folder and its subdirectories. And instead of printing that stuff to the console, I want to store that now in a file, so I just extend my command by this, so it will generate the ledger, data.csv. Yep. And now the content is in here. And now we just need to edit this file to add additional columns and specify the column names and so on. So I use again gedit for this. Okay, so like I said before, at the end we want to have 3 columns where the first column will be the paths to the files. So I will use the reserved keyword file to indicate the first column. And then we want to have 2 more columns. One will be the simulation and the other one will be the time. And these values are actually already part of the file path, so we need some way of extracting those. In gedit, there's a very convenient way of doing that with regular expressions. So I just use the shortcut Ctrl-H to call this Find and Replace menu. And I want to turn on regular expressions, and now I will just need to formulate one that will give me, or like split this file path into chunks. And I already prepared this, so it should actually pop up in the history at some point. Yep, here it already is. Let me see. Yep, this is a complete expression. And let me break it down. So the first part here just is this dot dash here at the beginning, and since the dot is a special character, I need to escape it. Yeah, and each of these brackets will be an individual chunk. So the next chunk is everything that comes before the next slash. So this will be our simulation. And then we have 3 dots, which means we will have 3 digits, which is the time. And then finally the rest of the file path we will ignore for now. So, and what I want to do is I want to replace this here first with the entire expression so I don't lose the file path. So for this I need to do this with these slash operators. So I will use /1 for the first chunk, second chunk, third chunk, fourth chunk, fifth chunk. So this will give me the complete file path. Then I want to have a comma, and then like you see I already prepared this once. So it will take the second chunk and the fourth chunk, where the second chunk is the simulation and the fourth chunk is the time step. If I now run replace all, we will see that we now have these additional columns that record the information we want. And this is a very easy way of just getting a cinema database up and running. So I now need to save, and I already have my cinema database. Yep, but actually to turn it into the final cinema database, we also need to change the extension here. So I will go one folder up, and instead of having temp, we will call this now temp.cdb. So now it's a cinema database. It has the data CSV file and the other files inside. And now let's jump to ParaView, and let's use this database we just created to do some processing. Okay, so let me start ParaView. I have a shortcut for this here, so just call ParaView. Okay, and here we are in the interface, and I want to start by reading our database. So I will use this source TTK cinema reader filter, but you can also access it with, for example, control spacebar, where I can just type in reader and call the cinema reader. And now I have to specify the database path. So I will go again to this folder where I stored my database. Let me quickly look that up again. That's this one right here. So I can type this down here. And here's the database. And when I hit now apply, it will look for the data CSV file and read it in. There's currently a small bug in ParaView that it will always open the database and showing you in the spreadsheet view the field data, but actually you want to look at the row data. So here you can see the entire database content, which we specified in the data CSV file, and now I want to get a subset of this. So for this we can use the cinema query node. So just to show you again, you can also access this with filters, TTK cinema, and here's the cinema query. But yeah, I will use the shortcut control space again and run the cinema query node. And here I want to specify an SQL command that will get me a subset of this table. An easy example here is that I want to take everything from that table where the simulation corresponds to simulation uppercase, where the simulation corresponds to run 01, and let's say we want to order the results by time. Okay, so when I run this, I can see the result of the query, and it's now also ordered in time, and I get all these results. And a common way of working with this data is also that I can use some SQL additional commands, like I can limit my results. Let's, for example, only take 50 rows, and I want to skip the first 20 because they might be uninteresting. So now that I specified what data products I'm interested in, I want to load them into ParaView. For this, I will use another cinema filter, which is called cinema product reader. And since this will retrieve a 3D object, I want to show this here in the 3D view. So I click here on the cinema reader and call again the cinema product reader. So this is different to the cinema reader. The cinema reader just accesses the data CSV file to see what's in there, and I can use the cinema product reader to actually load products. And the cinema product reader needs to know which column it should use to look for files. And this is why we have this reserved keyword file, because this is the standard, the default column which it will use. But if you have some more advanced databases, you could have different columns with different names, and then you could choose the one you want. But yeah, in this case we just go with the default, with the file, and we just hit apply. And after it's done, it just created a BTK multi-block dataset where each row here corresponds to a block of the multi-block. So a nice tool I frequently use is this multi-block inspector here, where you can cycle through the individual blocks. And like I said, each of these here corresponds now to one of these rows here. And there's also an additional mechanism behind this, that the product reader, when it reads one of these files, it will attach as field data the row data it came from. So, for example, here this first block has a field data that specifies its simulation and time. So it knows, oh yeah, I'm the time step 21 from that and that simulation. Okay, and now that the data is in ParaView, we can do processing as usual. Let's say we want to have a small overview of what's going on in the data. So in this case, this is an example from the viscous finger data set. So it's some salt concentration in water. And let's just say we want to have some slices to see how the salt concentration behaves over time. So we can just run on this on these data products the slice operator, and we can just leave everything on default and hit apply. And here we can see the result from this extraction. And since all of these blocks share the same spatial coordinate, basically we just have now for each time step a slice that is located right here. So it will just pick one randomly, it will show to us. But if we want to cycle through them individually, we can do it with this, for example, the multi-block inspector, where I can say, turn please everything off, just show me the first time step, or here the last time steps. But obviously this is kind of stupid if you want to navigate big data sets like this. So there's an additional filter in TTK that will arrange these slices, and this is what we're going to use next, which is the so-called cinema layout filter. Let me call this here again. Here is the cinema layout filter. And now I have to specify how to lay out these slices. As you can see here with the 3D widget, that we have basically in the data set, the z-axis corresponds to the height of the cylinder. And now we want to use, for example, y to indicate time. So let's say for the columns we will use y, and for the rows we will use z. So we will stack them on top if we want to. And if we don't change anything here, it will just create this grid layout I just talked about. So we can use some auto layout functions here to get this in a nice overview. And I can just close the spreadsheet view now if we don't need it anymore. And now we see these things next to each other. And by default, it will try to produce a compact layout. Oops. So it will try to create some sort of quad. But we can specify, for example, how many rows we want, so that it will optimize in one or the other ways. So if, for example, we want to have a time series, we could just say we only want to have one row. So it will just create a line, basically. This is what we see here. We can also do some more processing on this. So we could, for example, go ahead and say from this layout, please threshold, for example, the salt concentration that's behind this, and show me all salt concentrations that are above, let's say, 28 till the maximum concentration, just to make sure that we catch everything. Let's do it here is 200. And as you can see here, we can now have a nice overview of what's going on inside the data before we do some further processing. And let's say for some reason you want to store the products we just created in the new cinema database. So we can just take whatever input we want. In this case, let's just take here the input from this threshold and call a cinema writer filter. Here it is. Okay. And the first thing is we need to specify where we want to store the database. Okay. So we can go ahead and just say, for example, we will store it next to our temporary database. So I will pick this data folder as my root and then say temp2.cdb. And then I have these options here. So the first thing, which is obvious, is of course the compression level. So if you have really huge data sets and then of course it makes sense to have a high compression level, but that will also mean that it will take a long time to store these products. So if you just want to try something out, usually it's better to actually have a low compression level, and then when you want to create production level cinema databases, then it's nice to increase this level. And then here, this parameter overwrite database basically just determines if you want to clear the database every time this pipeline is executed and then store the current products inside, or if you want to build databases iteratively. I use this frequently to run these TTK, VTK pipelines on a cluster in parallel, where they all write into the same cinema database folder. And for this, of course, we need to disable the overwrite database flag. Otherwise, all clusters would overwrite their results instead of appending the database. So, but here for this debugging purposes, it's of course okay to just have it enabled, so that every time you execute the pipeline, the database basically gets recreated. Okay, so let's do this. So I hit apply, and now it created the database. And now let's just have a look inside. So here's the one we used the entire time, and next to it now there's this temp2.cdb file, and in this case the cinema writer automatically creates the file database store, so this is not human readable anymore because it does some optimization, compression, and so on. But we still have the database ledger, and let's have a look what it automatically stores here. So the first thing you see, it still knows which simulation and which time step belong to each individual block, because the cinema product reader was able to attach this information when it read the products. So the cinema writer filter knew that individual blocks have some specific context, and this is why it was able to automatically generate this data.csv file. And with this mechanism, you can also manually augment these products. So let me get back here to ParaView. So if, for example, here I want to store the threshold value I computed for these slices, I can do this by manually setting field data, attaching it to it, and the cinema writer will also store that. And for some more of these advanced uses, I will show you in the next video. Okay, so that's it for now, and thanks for watching.